Welcome to Lesson 49, Writing Equations in Slope-Intercept Form. We're going to be reviewing slope-intercept form, which you learned in pre-algebra or course 3, whatever book you were in before you came to this class, algebra. And so just as a reminder, at the top of your notes, I've included a box that has slope-intercept form, which is y equals mx plus b. And just a reminder that the m stands for slope and the b stands for y-intercept. So those letters will always stand for those two things. So looking at the first example here, determine the slope and the y-intercept of each equation. If I were to write y equals mx plus b right underneath this equation, then you could see the 5 is right above the m, and the 7 is right above the b, and the x lines up with the x. Oops, I was going to use a different color for that. And the plus sign lines up with the plus sign. So you can see that the m equals 5, and the b equals 7. So the m is the slope. So if we were graphing this, it would be 5 over 1. And the b, the 7, is the y-intercept, which is where the line crosses the y-axis. The next example, the same thing, except this time it's not already in y-intercept or slope-intercept form, excuse me. So we have to solve the equation for y. Whenever you're given an equation that's not y equals mx plus b, you can solve it for y so that it is in the form that we would like it to be in. My iPad is squeaky today. So we need to have y on one side and everything else on another. So this term we want on one side of the equal sign, and we want the x term and the coefficient, which is the 6x and the plus 3, on the other side. So I'm going to move the negative 3y over. Instead of moving two things, I'll only have to move one. So I'm going to add 3y on each side, which is the inverse operation of minus 3y. So then I will have 6x plus 3 on one side and 3y on another. Now I'm not done because I still have a coefficient in front of the y, which I cannot have for slope-intercept form. I need to have y by itself. So I do the inverse operation of 3 times y, which is divide by 3. And remember, you have to divide everything by 3, all of the terms in the equation. So that's going to give me 6 divided by 3 and 3 divided by 3. So I will have 6 divided by 3 is 2x, and 3 divided by 3 is 1. So plus 1 equals, and the 3 divided by 3 here will become 1 times y, which is just y. So even though this is in a different, it's opposite what we usually would have, we can just switch what we have on each side of the equal sign. So we have y equals 2x plus 1, which is in slope-intercept form. And I'm actually out of room here, but I do need to label the slope and the y-intercept. So the slope, m, would be the 2, because it's in front of the x, and the y-intercept, b, would be 1, because it's plus 1. So there are my answers for that example. Moving on to the next example, I'm going to have you write in the definition of a solution of an equation with two variables. And this, when it says to find the solution of an equation with an x and a y, or it could be an m and an n, or a t and an s, it just depends on what the variables are. But if there are two variables, then it's usually a line, so you can find a point on that line, or the solution, a solution. Sometimes there's more than one. So it's an ordered pair, an x and a y value. My pen is not working. An ordered pair or a set my goodness, this is frustrating. I'm going to pause for a moment. Okay, sorry about that. I think my pen's working a little bit better now. But please write in the definition that an ordered pair, or the solution of an equation is an ordered pair or a set of ordered pairs that satisfies the equation, which means that it makes the equation true when those numbers are plugged in for the variables. So the next sample, we're going to graph each line using the equation that is in slope-intercept form for the first one. The second one we're going to have to rearrange so that it's in slope-intercept form. So the first one, if there is no y-intercept in the equation, you can assume that it's plus 0, which means that the y-intercept would just be 0. So the first point would be at 0, 0. And then to find the second point, we would use the slope, which would be 6 over 1, rise over run. So we'd go up 6, 1, 2, 3, 4, 5, 6, and over 1, and put another point. And then we can connect those points to make the line. Wow, my line is really crooked, sorry. You know what I mean, though. All right, the second equation we're going to have to rewrite so that it is in slope-intercept form. So the first thing we want to do is get the y term on the other side of the equation. So since this is a positive 3y or a plus 3y, we would have to subtract 3y on both sides. And then I'm going to continue underneath the graph here. So that would leave us with 5x plus 9 equals negative 3y. So then we would need to divide by negative 3 to get y by itself under each term. So these would cancel out to be 1, and we would have just y. And then we would have 5 divided by negative 3 would just be negative 5/3 x. And 9 divided by negative 3 would be negative 3. And then I'm going to put the y over here. So this is our equation. So our y-intercept is minus 3, which is negative 3. So we would put our point there on the y-axis. And our slope is negative 5/3. So I'm going to go up 5 and then backwards 2 to get my negative. The other option would be to go down 5, which I'll do that in another color. 1, 2, 3, 4, 5. That makes me off the graph, though, and over 2, which would be right here. Either way works just the same, and then you would just connect your points to get your line. Okay, moving on to the next example. This time we're given nice straight lines, and we have to find the equation for them. So we want to look for two things, the slope and the y-intercept. It's easiest to find the y-intercept first, which is where it crosses the y-axis, which is right there. So it's 2. And then the slope, we have to find another point on the line, which I'm going to use this one right here. And we need to count up and over. So we're going to go up 1 and over 1, 2, 3, 4. So that's up 1 and over 4, rise over run. So we have m equals 1/4. Then we just have to plug those in to our y equals mx plus b equation. So we would have y equals 1/4 x plus 2. Okay, and then our other graph here, where it crosses the y-axis is right here at -2. So b equals -2 this time. And the slope, rise over run, we need to find another point. So another point is right here at 0, -1. Or I'm sorry, -1, 0. I had that mixed up. So we're doing rise over 1. We're going to go up 2 and backwards 1. So 2 over 1, but we're going backwards 1, so that's a negative. So -2 over 1, which equals -2. So if we plug those into our equation, we would have y equals negative 2x minus 2. In our last example, we're going to take a situation and write an equation from it. So a health club offers several month-long classes. Club membership is $40 for the month and $15 for each class. So write an equation in slope-intercept form to represent the situation. So we could say that it's $40 for the month, if we're talking about the cost, plus $15 for each class that you want to take. So we don't know how many classes are taken, so that is the variable. And we can replace these with x and y. So if we want it in y equals mx plus b, we would have y equals, this would be our mx, so 15x, and this would be our b, plus 40. And that's it. Thank you for listening and taking notes.